This video is for Chemistry in the Earth System, Unit 2.1, Parts of the Atom. Today's essential question: how can the subatomic parts of an atom be used to identify it? Our first main idea: protons, neutrons, and electrons.
All atoms share the same basic structure. At the center, there's a dense nucleus with a positive charge. A cloud of negatively charged electrons orbit around the nucleus. The nucleus accounts for around 99.9% of the atom's total mass. The nucleus is composed of two types of nucleons, protons and neutrons. Protons have a positive charge, while neutrons have no charge. The atomic number is the number of protons in the nucleus and is denoted by the letter Z. The neutron number is the number of neutrons in the nucleus and is denoted by the letter N. The mass number is the total number of protons and neutrons in the nucleus and is denoted by the letter A. So, the mass number A equals the atomic number Z plus the neutron number N. Together, the atomic number Z and the neutron number N define the nuclear makeup of the atom, which is called the nuclide of the atom. When nuclides have the same atomic number Z but different neutron numbers N, they're called isotopes. For example, carbon-12 and carbon-14 are two isotopes of carbon. When nuclides have the same neutron number N but different atomic numbers Z, they're called isotones. For example, carbon-14 and oxygen-16 are isotones. When nuclides have the same mass number A, for example, nitrogen-14 and carbon-14, they're called isobars. The nucleons within a nucleus are bound together by the strong nuclear forces, the strongest of the four fundamental forces of nature. To summarize, all atoms are comprised of a nucleus, which itself is made up of positively charged protons and neutrally charged neutrons, with a cloud of negatively charged electrons orbiting the nucleus. The atomic number gives the number of protons in the nucleus, and the mass number gives the total number of protons and neutrons in the nucleus.
Our next main idea: identifying atoms. The atoms of each element differ from one another. These differences account for the various properties that the elements exhibit. The primary detail that identifies the atoms of a specific element is the number of protons within the nucleus, represented by Z, as previously stated. For example, an atom of the element hydrogen contains exactly one proton in its nucleus, no more, no less. This is true of all hydrogen atoms. An atom of the element helium contains exactly two protons in the nucleus, no more, no less. Again, this is true of all helium atoms. Thus, the atoms of each known element contain a specific and unique number of protons. Put another way, the atoms of different elements contain different numbers of protons in their nuclei. At this point, you should be able to generate a full and complete answer to today's essential question: how can the subatomic parts of the atom be used to identify it?